Hi, everybody. It's Alex Jarett, and welcome to Technology Executives Review, video or podcast. This is me. I'm your host and founder, Technology Executives Club, and also Technology Executives Review. And of course, it's brought to you by Technology Executives Club. And today we're going to feature Tony Sabaj, who's going to talk about this topic of zero trust. Hi, Tony. How are you?
Hey, Alex, how you doing?
Good, great. Good to see you. Just real quickly for everybody, let me introduce you, Tony. Tony happens to be on our board of advisors of the Technology Executives Club. Tony, thank you for doing that. And part of that is doing this show right here and sharing wisdom learned and insights that he's learned with us. And Tony is with the Office of the CTO, Cybersecurity Evangelist, and Head of America's Channel SEs at Checkpoint Software, which is a great software company focused on cybersecurity and all kinds of things in that area. So welcome, Tony.
Thanks, Alex. Glad to be here today.
Yeah, glad to have you here. We talk about the topic of zero trust. Just before we start, real quickly for me, what is this concept of zero trust? I looked it up. I do have a sense of it, but why is this so important? And then we'll get into the presentation.
I mean, it really has to do with the fundamental principle of security. Instead of going back to the Bush doctrine of, trust but verify, it is don't trust and also verify is really the best way of putting zero trust, is that essentially from a computing network interconnectivity of devices and data and networks is that you do not trust anything that you're connecting to until it's been verified. And that's really at the heart of what a zero trust architecture or principles are.
Got it. Well, that makes a lot of sense. It's funny you mentioned that because I've heard the trust but verify so many times from so many different people, including auditors who say that. So I know it's a different principle for people to go to zero trust, and I think it makes a lot of sense in today's world. With that, why don't you get started? I'll see you when you're done.
All right, sounds good. Thanks, Alex. So what I'm going to touch on here for the next 20, 25 minutes or so is really around the basics of zero trust, the principles, and then some of the common approaches of implementing a zero trust architecture. So first off, we'll define zero trust, what it means, what it doesn't mean. We'll explore sort of the zero trust journey, and we'll talk about how it's sort of a never-ending process, not in a bad way, but as in all things cybersecurity, they evolve and change over time. And then we'll look at some of the more common zero trust models out there and really which ones I believe are the most effective. So first, let's define zero trust and really what it means. And, Alex and I touched on this a little bit in the intro and gave a very, very, short answer to it. But what is really the zero trust framework? This was something that was coined by Forrester a few years ago. It's really a framework for designing not just networks, but designing the infrastructure or the information infrastructure of any organization or entity. And at the end of the day, what you're really trying to protect is the data, is really at the heart of it. And what has access to that data? You have networks, you have workloads, you have people, you have devices that are all trying to get access to that data. And putting controls in that zero trust mentality of don't trust anyone and verify every single attempt at accessing that data, and then being able to wrap automation and orchestration around this, and visibility and analytics. And the automation and orchestration is very important to be able to keep your zero trust architecture up to date as things change within everybody's environment and in the security and technology space. And then having the visibility and analytics to make sure that you're actually meeting your zero trust goals and you don't have any holes, or you don't have issues that you haven't been able to take care of, and be able to report on the success of your zero trust infrastructure. And this becomes important also from a implementation standpoint, but in most organizations, this costs money to implement. And that visibility and analytics is going to be able to show your progress to the people that are actually funding your zero trust initiatives. So this is one example of a definition of zero trust. This is Forrester's definition and the way they visualize it. And we'll talk about a few others near the end of the presentation and kind of which ones make the most sense to me. So at the heart of zero trust, I mean, really what we're trying to do is we're trying to reduce risk. And if you look at any risk model, regardless of whether it's information risk, cybersecurity risk, car insurance, financial risk, is usually defined by the impact times the probability of something happening. So at the end of the day, we're really trying to lower risk by either removing vulnerabilities, mitigating those vulnerabilities, or reducing the actuality of that vulnerability being exploited, and then also decreasing the impact of that vulnerability. So even if something does get exploited or breached or hacked, that the impact, what they have access to, is very much limited. And that's really at the key of zero trust, is being able to lower the probability and the impact of that to overall reduce the risk. And if you look at this from a non-cybersecurity perspective, everybody out there has car insurance. If you have a car, mandated by law to at least have liability insurance, but I'm assuming most of you carry some type of full coverage to insure your own car. If you've got a car that's worth $5,000 to replace, you're probably not going to spend more than a few $100s a year to insure that car. You're certainly not going to spend more than $5,000 a year to insure that car, because if it's a total loss, you just go out and buy a new car for less than what you've cost to protect it, or at least have replacement insurance cost on it. And that's the other thing that we have to look at from a cybersecurity perspective is, obviously we want to make things as secure as possible. None of us have unlimited budgets or unlimited resources to implement, everything everywhere. And also, if you over implement security, you get in the way of business, and then people find ways around it, or the security becomes less because people need the ease of doing business. So, one of the things I talked about with Alex, I think last time we talked, was using security as an enabling technology to be able to do things that you couldn't do previously, by making it more secure and hitting regulations and different security frameworks. So we'll get more into exactly what zero trust means, but at the end of the day, we're really just trying to reduce the risk through limiting the impact and the probability of cybersecurity events happening. So one of the big, sort of misconceptions or things out there around zero trust that I see is really the difference between specific technologies and a zero trust framework. So a zero trust framework is really more of a philosophy. It's an architecture. It's something that you're striving for within your organization or your entity to really provide that least privileged access between data, users, devices, APIs, workloads, networks, all the different entities in an environment that need to communicate with each other and have access to data. Making sure that those entities have the least amount of privilege to get their job done, and are isolated to the point to where if they are breached, their impact is much lessened. There are solutions out there called zero trust network access, which are really more of a product, which is something you buy or implement to help move your zero trust journey forward. But it is one piece of zero trust, and we'll get into a few of these different areas. But a lot of people think that implementing zero trust network access is going to make you achieve a zero trust framework, and it's not. It's a important part, but it's actually a fairly small part of what you're doing from zero trust. So there's other zero trust initiatives or products out there. So there's zero trust, network access, network security, container architecture, DevOps, workload access. So there's different solutions that all feed into a larger zero trust solution. So this is really kind of one of the big misconceptions, is that zero trust is not a single product or a platform. It's not something that you can buy. It's a security framework built around the principle of least privileged. So attempting to buy zero trust as a product set is going to set you up for failure. Now, there are obviously lots of third-party products out there that help you implement zero trust, but you cannot buy zero trust. It is a philosophy. It is a framework. It is something you have to implement within your organization from top to bottom, from a technology and user perspective. And you really want to make sure that your zero trust architecture fits with your business objectives. If your security is keeping your organizations from doing business, you're not going to be very secure for long, because you can't stand in the way of your organization doing their day-to-day business. So let's take a little bit about the zero trust journey. And I think the term journey is overused sometimes, but in this case, it's a never-ending journey. Is that you're always implementing zero trust, but there are different stages of it, and we'll discuss those here in a second. So really, zero trust, the ultimate goal is to get to, what we call explicit trust. And it really starts with, implicit trust, which is really more, static policies, very little, identity sharing amongst your organization. There's this term of, segmentation within networks and applications. So doing things like macro segmentation, like saying, okay, this office is separate from this office, but not doing it at a floor by floor perspective, or a user base versus a server base. And that's kind of more of the micro segmentation. And we get into things like nano segmentation. And sometimes this creates friction between business units, because you don't have a lot of integration. You've got different business units or different groups within an organization trying to do two different things and implementing security and trying to implement, implicit trust their own way. But as we move along in the journey, we get to, substantial trust, which we're now making policies that are identity aware, where we're starting to share identity information across different applications and different parts of the organization, but not completely federated. We don't have a single source of identity. The access isn't always fully aligned with the rest of the organization. So we're getting better. We're starting to add, identity into the mix of this, but we're not quite there yet. So to kind of compare and contrast this, this is like implicit trust. If we look at it from a very simple, let's say a firewall rule perspective, is that all internal users have access to, HTTP and HTTPS on the internet. Now, I'm not actually authenticating my internal users. I'm just saying if they're on the internal network, they're an internal user. And if it looks like HTTP or web traffic, I'm going to allow it out to the internet. Whereas in substantial trust, I may say something like, oh, okay, only HR has access to performance review data. Well, I can authenticate whether someone's in HR or not, but I can't necessarily determine whether they're looking at performance review data, which really kind of brings us to the contextual trust, where not only are we, identifying the person or the entity that's accessing this data, but we're also identifying the data itself. So it's not only identity aware, but it's also context aware. So now in this case, I can actually say only HR has access to performance review data, because not only am I authenticating and federating that I know who is in HR and who's not, I can also look at the data they're accessing and say, hey, this is performance review data, so the average person in the organization doesn't have access to it. So I'm actually implementing data-aware policies, not just location, network, and then identity-aware policies, but also the data-aware policies. And this is really where, kind of the big leap happens is from substantial trust to contextual trust. And then getting into explicit trust, which is really sort of I don't want to say the end goal, but the sort of top tier, because this is always evolving, is really having that, dynamic, business-driven policies across the entire environment. So you're including things like your network and your cloud infrastructure and APIs and containers, and we'll get a little bit more into that. And being able to do, micro, macro, and even nano segmentation, and we'll touch on those topics in a minute, across the entire environment, whether it's in a data center, whether it's in like a hybrid cloud solution, a public cloud solution, integrating, the endpoints within the environment, and even looking at your software supply chain and your continuous integration and continuous development, your own coding and applications that are building your environment. So this is really the ultimate goal of implicit trust on your zero trust journey, and we'll talk a little bit in more detail on how this applies to sort of the main pieces of zero trust. So if we look at zero trust with identities and data, and when we talk about identities, we're not always just talking about users. We're talking about any entity that has access to data. So initially, as we start with implicit trust, maybe we're just talking about authenticating users. Maybe we start adding things like multi-factor authentication, and then we're getting into identity-aware firewalls and network access, which is really just firewall as a service. And we're not only authenticating users, but we're also starting to authenticate where they're coming from, what data they're getting access to, but also what functions and what applications have access to that data. So if, again, we take the example of only HR has access to performance review data, I can authenticate that somebody's in HR. I can determine whether that's actually, sensitive information that only HR should have access to. But what about all the other applications and functions in the environment that have access to that data? Are those functions accessible by people that shouldn't have that function has access to that data, but maybe people that have access to that function shouldn't have access to that data? So it's really more than just authenticating users, but it's also authenticating the different entities within the environment and doing more role-based authentication and not just individual user-based authentication. And then when we get into, and we'll use the term, macro segmentation and micro segmentation in a couple of different contexts. Usually this is referred to in the terms of networking, but in this case, we're going to talk about it in the terms of data, is being able to segment your data so that if a certain data store is breached, or not necessarily breached on purpose, but gives accidental access, that information is contained, and maybe the unauthorized access is limited to a certain subset of data and not all the data. So we'll use this term micro, macro, and nano segmentation, in the context of data, in the context of networks, here in a second. But really looking at that relationship between all identities that have access to data and the data itself and what kind of data it is, and being able to implement that across the entire environment. And if we look at it from a device perspective, and again, we're kind of looking at the four main pillars of the Forrester model. If we look at it from a device perspective, we're not just talking about the actual device, but actually looking inside that device. So let's pretend we're talking about a Windows operating system, because that's what most people are familiar with. You have applications running on top of libraries, on top of operating systems, on top of hardware, and you have different places to inject security. Do applications have access to each other? What parts of the operating system should the applications have access to? Should my web browser have access to, my USB ports, or is that something that's even allowed in the environment? Is my hard disk encrypted, so that if the laptop itself or the machine itself is stolen or lost, you can ensure that data stays private? What kind of data can leave the machine? What kind of data can you put on the machine? What types of networks can it connect to? As a user, how secure my machine is may may actually determine what kind of data I have access to. So if I'm in HR and I have access to performance review data, maybe I can only get to that from a secured device that's controlled by the organization, by my company, and not from my personal cell phone or my personal laptop. So it's another variable. It's another decision tree within the access to data. And that's sort of, how we look at it. And then as we move to, explicit trust and sort of get in the middle, we start looking at applications themselves and how reputable these applications are. What does it have access to? You see this a lot when we talk about mobile devices. Every time you install an app on your iPhone or your Android, it wants access to the microphone. It wants access to your contacts. It wants access to these different functions of your mobile device. And if I'm downloading a solitaire game and it asks me for access to my contacts, I'm not going to give it to it because a silly game that I play in between meetings doesn't need to have access to my contacts. That's an example of zero trust or violating zero trust, is that app doesn't need access to my contacts, so I'm not going to give it to it. I'm going to give it the least amount of privileges it does to be able to play the game. And that's a very simple example. But even looking at it from that way, and then as we move into explicit trust, is actually being able to put security controls around that solution and being able to block things before they even come in, looking at apps or looking at certain applications running on the device and saying, hey, this is overly permissive. We're going to block it. We're going to sandbox it, or we're going to limit its connectivity or access, so then you can operate in a more secure manner. So it's really looking at it from a device perspective, and what that device is another input into whether I have access to the specific data or applications that I'm trying to get access to. And if we look at zero trust from a network perspective, and this is kind of where everybody starts from a zero trust perspective, they think, oh, I've got to put firewalls and SASE solutions and SD-WAN solutions, in my environment to be able to segment and create network access policies within the environment. Very important to zero trust, but it's, again, just a small part of zero trust. And as I'll show you at the end, becomes less and less important as time moves on. But still important to be able to, segment your networks physically between, firewalls or security gateways, whether you're connecting them, over the internet, over VPNs, or whether you're connecting them, via, MPLS or private links, those types of connectivity. And then having some segmentation within your data centers of, separating your, user population from your data stores, making sure that they don't intermix. And then as we move to explicit trust, and this is really more of that digital transformation journey of my data no longer 100% resides in my own data center. I've got data in SaaS applications. I've got data in public cloud. I've maybe got data in remote offices. I've got users that don't need, sometimes don't ever need access back to data centers. They're just going to SaaS applications and the internet. Why backhaul the traffic? So being able to do things like firewall as a service and SD-WAN, being able to have that micro segmentation, but still being able to implement zero trust of knowing who that user is, where they're coming from, what type of device they're coming from, what data and applications are they trying to access, and making your determination based on that, without having to have disparate policies all over your environment. And we'll talk a little bit more about how this actually gets implemented in the real world with a couple of different zero trust models. But this is kind of where your traditional, this is where your ZTNA and your SASE services come into play. And this is kind of where people start with zero trust. I didn't start with that because I wanted to kind of introduce some of the non-obvious zero trust implementations. But this is where people usually start, is with zero trust around their networks and user-based sort of remote access to those applications. And then, as we look at zero trust within, public and private clouds and segmentation, this is separated from from the network access, because once you move into a public cloud and even, to some extent, private and hybrid clouds, is that your traditional network access kind of goes out the window, because you don't have that same layer, 3 through 7 visibility to be able to make these types of determinations. So when you get into more cloud security and zero trust, yes, you've got some of the, east, west, and north, south traffic that you can protect with kind of traditional security gateways, which is very important and a big part of it. But once you're inside the cloud, you almost have to look at things from an API perspective and not from a traditional networking perspective, because the sort of traditional networking goes out the window within at least what's visible to you in public clouds. So being able to segment different, VPCs or VNets or subnets, depending on which cloud provider you're using and what they call them. So being able to sort of micro segment, but as we get into nano segmentation, we really have to look at the workloads and containers and web front ends, which kind of leads us into kind of the next one is zero trust around workloads. And this is probably the most overlooked segment of zero trust. And this is where I see a lot of organizations almost completely ignore this. And the reason I've separated this from kind of the zero trust cloud that I just showed you is that if we look at workloads and, specifically, let's just use the, whether it's containers or functions within a public cloud, is these can exist outside of a public cloud environment. So I can run, Dockers and Kubernetes within VMware or, in my own data center. So we have to look at this outside of just public cloud infrastructure, even though most use cases are in public cloud. But looking at things like containers and functions, again, where we've lost that ability to look at things with a traditional network security solution like a firewall security gateway, and we have to look at things at an application level, on an API level. We have to peek inside of containers. We have to make sure that if I've got a web server, it's making API calls to a S3 bucket or a database front end that's eventually going to an S3 bucket in AWS. That web application only can make the function calls that is needed to get its job done and only has access to the data that it needs to serve up and isn't overly permissive. These are things that no human is going to be able to keep up with. They can come up with the idea and what should have access. And this is where that automation really comes into play, is when you start talking about, a cloud environment that may have thousands of little applications in it and maybe doing millions of function calls. If you start looking at, Lambda and functions within a public cloud environment, no human can secure that. And this is where the automation and AI built policies come into play, of being able to address the zero trust aspect of, what could be tens of millions of different API calls in a single day in a, average size cloud environment, and being able to have that automation and orchestration around it. So we've kind of covered the, kind of the kind of 4 main pillars, or really 5 if you include data, of the Forrester model. So let's take a look at a couple of other zero trust models, and I'll talk about which one's my personal favorite, and hopefully will be yours after this presentation. So if we look at the Gartner cybersecurity mesh architecture, this is sort of their zero trust architecture, and it's changed slightly, but it's looking at all these sort of different point solutions out here, going back to, an operational playbook where you're having policy and posture, shared identity, to an identity fabric or a federated identity, and then a security intelligence layer that's sharing external security information and also security that's learned from all these different devices or solutions out there into one central place. and making sure it's covered from a device, a server, workload perspective, SaaS, public cloud, hybrid cloud, different devices. I'm not a huge fan of the Gartner model for a couple of reasons. One, they name a lot of different point solutions, and people think that if they get all these point solutions, they'll have zero trust. The zero trust isn't achieved until, put it simply, all these lines are connected, and this is the hard part: is connecting these. Is connecting these lines. So it's good that it kind of shows you where you should look, but I'm not a huge fan of the cybersecurity mesh architecture. It's good because it kind of shows you all the different sort of, different applications you kind of need to implement or buy to get to zero trust, but it doesn't tell you how to connect these lines, and that's the hard part. So if we look at the NIST model, which is sort of my favorite model, I'll show you my favorite model here in a second. What I like about the NIST model is, the Gartner one needs to be updated like constantly as new technologies come out. What I like about the NIST model is it's very foundational and really looks at how the architecture should be and doesn't get into necessarily point solutions, where they have this concept of a policy enforcement point. That policy enforcement point really relates back to all the different sort of point solutions in the Gartner cybersecurity mesh, where I have all these different policy enforcement points that is getting their information from a policy decision point or policy engine that's generating the policies and saying, okay, hey, my firewalls need to implement the same DLP policies that my endpoint's implementing, that my SASE solution's implementing, that my database security solution is implementing. So it's a single truth for a policy, and then letting these different solutions implement the same policy consistently across the entire organization, and being able to identify the user and the device and what data they're getting access to. And then you have sort of what they call the policy information point, which is really where it's gathering information from, whether it's your identity provider, whether it's that shared security fabric, different external inputs that are driving that policy decision engine. So let's go back to the workload example of, I may have millions of function calls, Lambda function calls in AWS. I want to make sure that those function calls only have the least amount of privilege. As I said, no human's going to go in there and determine that, because you'd have to have a lot of people do it. So you have external security tools that are looking at it saying, okay, this is what this function is trying to do. Here's the minimum access that it needs to get its job done. Make sure that's what's implemented, or at least report that it's violating that. And then you have a policy administration point, which is where the input comes in, where you have your SOC dashboards or your policy dashboards, where you're actually entering the information, viewing the information, and getting your analytics out of this point. So as I said, this is kind of my favorite. So I cheat a little bit, and what I really like to do is layer the Forrester model on top of the NIST model. So this is just a squashed down version of the NIST model here on the bottom, and then really making that policy enforcement point around your users, your devices, your networks, your workload, and your data. So if you use the concept of a data plane and control plane, this is where I'm enforcing the interaction of all these different entities. They're specific enough to where I cover everything, but they're generic enough that every time a new technology comes up, I don't have to update it like I do with the with the Gartner one. And then I have my control plane. This is where my decisions are being made. This is where my external inputs are coming from. This is where my reporting and my human input is coming from, and things like public key infrastructure are all part of this. So this is really my favorite sort of zero trust model, is layering the Forrester model on top of the NIST model, And this is kind of what I like to strive for and work with organizations about. Now, we've talked about, a zero trust journey. And again, that term is somewhat overused, but in this case, it's appropriate. As I said, most people start with the network, and they start implementing zero trust. And as you go through the zero trust journey, your traditional network security becomes less important. I'm saying it doesn't become important at all. It's still very important, but it becomes less important in comparison to some of the other technologies. So, endpoint and host control becomes important, and then less important as we're, putting security closer to the end user and the data, as opposed to trying to do security with intermediary devices like, security gateways, routers, and firewalls. So as we move security closer to the edge, the network controls, still very important from a network security perspective, but from a zero trust perspective, become less important in implementing zero trust because they're not seeing the same things that they used to be able to see. I made the comment of, once we start getting into public cloud and containers, a traditional layer, network layer control isn't going to be able to see that data. That data is flowing within the cloud. Yes, the underlying technology is still networking, but it's being called with, APIs that a traditional, router or firewall isn't going to see. So this is where most people start. They start implementing, network controls to implement zero trust. And then they start, as they move through that journey of implicit trust to substantial trust, explicit trust, the host controls and then the data controls become the most important as far as zero trust is concerned. And, we talked about sort of those, 4 main pillars of zero trust. You could be on a different path on each one of those pillars. So your network, zero trust network journey might be further along than your workload journey within zero trust. So it doesn't mean that everything has to follow the same timeline across the entire organization. But this is traditionally, what we see from a importance as we move through the zero trust journey. So to kind of summarize and kind of hit the key points is that zero trust network access does not equal zero trust. It is a piece of zero trust, a very important piece, but makes up a fairly small percentage of your overall zero trust efforts. And don't forget about your cloud and your entities and your workloads. Your functions and containers within your cloud have just as much access to data and are just as much important as an end user or some type of role within your organization. So making sure that you look at your entire environment and not just what you can see with traditional network controls, and that your zero trust journey never ends. There's never an endpoint. I have never seen a zero trust project ever be completed. That doesn't mean that they're not successful. It just means that as soon as you've got to the end of it, there's always more that you need to do. There's new technology, there's new environments, there's new applications that you need to make part of that. But hopefully you have the process down to where those new applications are introduced at a much later stage in the zero trust journey than starting from scratch every time you have a new technology or new implementation within your organization. So again, zero trust is an ongoing journey. It's not something you can buy. It's a methodology. It's a framework. It's a philosophy if you want to get a little zen. And the implementation of buying a bunch of point solutions and even getting them running doesn't equate to zero trust. If you go back to that Gartner model, you got to get those lines working, and those lines are harder than implementing all those point solutions on their own. So, make sure you realize that zero trust is that journey, and it's more of a philosophy and a framework. So, I want to thank you for your time today. Here's my contact information, and that QR code is a link to a Checkpoint site that talks a little bit about zero trust and actually some of the technologies and concepts that we talked about today. So again, thank you for your time, and I'll turn it back over to you, Alex.
Well, that was awesome. Well, anyways, that was great. I do have some questions for you. I mean, it was an awesome presentation, but I kind of created some questions that I thought somebody watching this might ask Tony. Is that all right if we go over a couple of those?
Sure, Alex.
Can you discuss the main challenges organizations face when implementing a zero trust architecture, and how can these challenges be mitigated?
Sure. So I mentioned a couple during the presentation that I see, kind of the one being really ignoring the internals of public cloud, the workloads, the containers, the function calls, where you don't have that traditional sort of network layer connectivity to be able to protect against. And there are ways of implementing zero trust from an API perspective, as opposed from a traditional firewall blocking type perspective. The other thing is, when you're looking at roles, focusing just on users and networks, as opposed to having those roles apply to any entity that has access to your data. So it could be an application talking to another application, or an application trying to get data from a data source, making sure that that application has its least privileged access to that data. Again, it's important that you focus on your users and what they have access to, but it's as important to focus on the applications and what level of access they have to the data. So if those applications are actually breached by a person or a bad actor, that they don't accidentally have access to more data. And this goes back to that micro segmentation of data too.
Yeah.
Of looking at, if something does get breached, I'm limiting the impact by this application only has access to this subset of data, and that's all it needs to perform its duties.
I think that example you gave was just as an illustration on the cell phone, right? Where you said there's an app. Did I get that right?
And where everybody's installed an app, and it asks for all sorts of access, and you're like, it doesn't need access to my contacts. It doesn't need access to my calendar. Why does my solitaire game need to know what I'm doing tomorrow? It doesn't.
Yeah. Why does it need? So it can put up a message, say, hey, I know you're doing nothing right now.
Right.
How about a game of solitaire? All right. So that's good. So that makes a lot of sense. So that's the challenge. That's one of the big challenge. Okay. So next question. How does zero trust impact network design and segmentation? And what steps should an organization take in adapting their existing infrastructure?
Yeah, so I think when people look at zero trust from a kind of a traditional networking aspect, which is a huge part of zero trust, is we talk about the micro segmentation, nano segmentation. This doesn't always necessarily mean that it has to be physical separation. They have to go out and buy a gazillion switches and routers to physically separate devices. This can be done in a software perspective, or a virtual networking perspective, where I can say, okay, I want all of my web servers that are serving up public information to be on the same network segment. I don't have to physically move those servers. I don't even have to physically move them from even a VLAN perspective. I could actually create firewall policies to say, okay, these groups of servers only have this amount of access. And if I have enough policy enforcement points, as I showed out in the presentation, I can virtually segment those types of devices. Or, if I can't segment my users from my servers physically, again, I could use a traditional firewall to say, okay, all of my end users need to be completely separated from my servers. I'm not going to allow, except for the bare minimum, I'm not going to allow communication between my end users and my server environments, even though they may be sharing the same, physical wires. I can, with firewalls and automated policies, enforce that nano and micro segmentation without having to rewire and recable, or mess with the access points of wireless networking. I can do it with software and a more software defined perspective.
That's interesting. The last question is, what role does identity and access management play in a zero trust strategy? And how can organizations ensure robust identity and access management practices?
Yeah, so the identity and access management is really at the forefront of
Uh-huh.
zero trust. We're talking about being able to identify a user, an entity, a workload, and then being able to apply some type of controls that again are contextual based, database, data aware, also network and device aware. But
Yeah.
being able to identify who that entity is, if we use a simple example of a user. I want to be able to identify who that user is. You don't want to have to authenticate that user every time they want access to something. So this is where an identity access management can not only hold the policies and be able to push those down to your enforcement points, wherever they may be, but also be able to broker and federate your identity. So, you're not going to be able to authenticate, some people may be authenticating via AD, some people may be authenticating via, some type of MFA or one-time password, or through some type of VPN client. Not that you want to have 1,000 different data stores, but no organization is going to have one data or user store of all their users. So you need an identity access management solution to be that one data store that's getting the feeds from all the different authentication methods and verifying that, okay, I'm Tony, I'm in HR, which means that I can have access to performance review data. If I use the example that I've used a couple times in the presentation, I don't want to have to, I don't want to have to authenticate 5 times just to find out that I'm in HR. So that identity access management can not only hold the policies and help enforce those policies, but be that single source of truth for identifying users and entities and then what they should have access to.
Got it. Got it. This is complicated. I got to
It
say,
is.
it's complicated. And when I look at that chart, I'm like, yeah, I can see how this is a journey, but I know one of the principles I've done enough cybersecurity events is, you keep working at it, you keep working at it, you keep working at it, it gets stronger and stronger and stronger. But with all that, things are still going to happen.
Yes.
So I think I don't know. I'm guessing the way to go with this is just be ready for what happens, but following these procedures can certainly minimize the overall risk. That's what you were saying at the beginning, right?
Yeah, that's yeah. I mean, if you look at the kind of the busy chart here, is this is really where kind of that micro and nano segmentation comes in.
Yeah.
Is it limits the impact. So if I do have a data breach, the data that was breached was very minimal. It's not the entire database. It's one subset of data that there was some vulnerability in some web app, but that web app only had access to the data that it needs. It doesn't have unfettered access to the entire database that it happens to be connected to. Same thing with network protection, network and, micro and nano segmentation. If a certain part of my network is breached, I've at least contained it. If you even go back to, ships, they have their flood doors. So if there's a flood, you can shut off the rest of the ship and the ship won't sink. It's the same concept, just, at a, more digital scale than a physical scale.
Interesting. Yeah, this chart makes a lot of sense to me. I mean, I like that metaphor that you used with the car insurance. I mean, if the car is worth $5,000 or $10,000, it's for most people, it's not going to be worth insuring it.
Right.
You got to insure the bodily harm or things like that, and whatever the state requires.
There's the mandated stuff I have to do to be able to legally drive.
Yeah.
But I don't have to insure my car. I just have to insure somebody else I hit.
Yeah. So if it's your core, if you're a healthcare organization, it's your core healthcare data. You got to protect that because of compliance issues, I assume.
Yeah, I mean, there's compliance stuff that you have to do legally.
Yeah.
And you have to do that, and whether it fits into your model or not, you have to make sure you're compliant. But usually at the heart of a lot of the compliance when it comes to data, it comes down to zero trust anyway. It comes down to HIPAA is, if you implement zero trust properly, and this is something that I think we talked about last time too.
We did.
Is there's a lot of external compliance, whether it's HIPAA or whether it's GDPR, whether it's, GLBA or, put any four letters together and there's a compliance for it, depending on what industry you're in. What I always tell people is implement a good security architecture or zero trust architecture in this case, and then look at where your gaps are, do a gap analysis of, I'm going to do it the right way. And then HIPAA says, oh, I have to do these two other things to be compliant and check the box.
Yeah.
So you do those two other things as opposed to starting with HIPAA and trying to build your entire controls around HIPAA. You end up becoming compliant, but sometimes less secure. And not that there's anything wrong with HIPAA. It's a good, regulation. But if you do it the right way and then do a gap analysis and fill in those gaps, as opposed to starting with HIPAA or GDPR or PCI or something like that, do it the right way up front and then do a gap analysis and fill in the gaps where you may not be quite hitting the check marks of that regulation or compliance.
Right. That makes a lot of sense. So what I was getting at for me for this chart was it helped me understand. The point is, if you have data, there's some data, it's all unfortunate if it gets compromised, but there's some data that's more valuable than other data, period.
Yeah. I mean, I'll use the example of, a press release, if there's a press release that Checkpoint's buying a company and it's going to be released on Thursday morning. If that gets out between now and Thursday, that has devastating effects because there's legal issues and, we don't want to tip off that we're buying a company. And again, this is not forward thinking. I don't know of anything, but once that press release has been released on Thursday at, 6 a.m. Pacific time or whatever it gets released, it's public information. Yeah. So if somebody breaches a web server that only has access to, public, press releases, it's like, well, what data they have access to? Yeah. Anybody with an internet connection has access to that data. So there's a time factor in this too, is that, that data is no longer important after a certain period of time. So, I don't need to spend all this money encrypting it.
Oh, that's interesting.
And protecting it is that, the press release gets written by PR on Monday. It's going to be released on Thursday. That data is only sensitive from, Monday afternoon to Thursday morning. So I only care what happens on Tuesday and Wednesday with that data. Once it's Thursday, it's public information. I don't care who reads it.
That's great.
So
that's good. Well, you've given us a lot of food for thought. Awesome presentation. Why don't we go back to your last slide again, and to reach out and connect with Tony, right?
I'll go real fast.
And one of the things, Tony, you told me that you had is that you have a white paper that describes pretty much everything in your presentation. And it also gives them a different information about how to reconnect with Checkpoint, which everybody would expect. But the core of it is actually just pure content, and it could be very helpful to people. Is that correct?
Yeah, very much so. In fact, this presentation is based off of that white paper, which is a framework for implementing zero trust, and you'll notice a lot of the same graphics in that white paper.
Sounds
but
good.
It goes into much more detail, so it's a much more in-depth read.
If you like this presentation, or if you just see this segment or watch any of our shorts from this segment or listen to it, be sure that you, if you're listening, by the way, go to our site, technologyexecutivesclub.com. In fact, I'll show everybody, but Technology Executives Club, go to Board of Advisors, and then you can find Tony and connect with him through LinkedIn, or it's asabaj@checkpoint.com. And if you're watching, you've got the QR code, you can just do it. And Tony can send you the white paper. Tony, great job. Hang in there. Let me close out I'm going to take back the slides. It's a really terrific job. I appreciate you making this presentation for the community, for the industry at large. And you ought to be able to see my slide, correct? That was today's presentation. Great job. Don't forget, you can see all our videos at technologyexecutivesclub.com, and listen to our podcast on Apple and Spotify. It's under Technology Executives Review. That's the name of our podcast. While you're at our website, join our complimentary Insiders Club. I give you lots of awesome goodies to join our subscription list you get on our newsletter. The newsletter is great because it tells you about great videos like this. And if you want to get involved and be a regular on our media network, reach out and ask us about our Board of Advisors program, because our Board of Advisors is actually the Board of Advisors to the technology community. And you can book a discovery call on our site. With that, thank you for attending, Tony. Thanks again for giving an
Thanks,
awesome
Alex.
presentation. We appreciate you. And everybody, it's our honor to serve you and your team. Please visit us at technologyexecutivesclub.com.